Good day everyone! Welcome to our channel, and today we will discuss about chapter 5 of the book Nature's Numbers by Ian Stewart, entitled Violins to Videos. It all started when the Greeks discovered that a pitch of the tone is determined by the frequency of vibration, where each frequency corresponds to a particular configuration of the moving string, and the same string may take on many different forms. This led to a long thread of discoveries about what strings could do. Later on, in 1714, Brooke Taylor, an English mathematician, determined the fundamental vibrational frequency of a violin string in terms of its length, tension, and density. But it wasn't until 32 years later that Jean-Léron d'Alembert established that many violin string vibrations are not sinusoidal standing waves. Then, in 1748, Leonard Euler, a Swiss mathematician, invented and solved the wave equation for a string, but Daniel Bernoulli proposed a unique solution to the wave equation, which caused heated debate. But it turns out both solution is correct. As the game of violin was solved, mathematicians began to look for a new mission.
With a better understanding of the wave equation, mathematicians decided that it was time to move outside the musical arena and head for a new conquest. Euler created a wave equation for the two-dimensional vibrational instrument known as the drum. It describes how the vertical displacement of the drum skin changes throughout time. According to its physical interpretation, the amount of average strain applied to the drum corresponds to how quickly a small area of its skin accelerates. As a result, it provides an equation that is similar to a one-dimensional wave equation but has spatial rates in two separate directions. The drums are different from the violin in terms of size and boundary because the violin has fixed ends. The solutions to the wave equation depend on the boundary condition. The drum skin's range of motion is constrained. The physics of music would eventually be explained by the use of this equation. To begin with, we are all aware that sound is a wave, more specifically, a longitudinal wave. This indicates that the medium through which the wave travels oscillates in the same direction as the wave. Greek scientists discovered that a string may vibrate at a wide range of frequencies. It demonstrated how the note placements affect the pitch.
Standing waves are a special sort of wave found in musical instruments, particularly strings, wind, and brass. They are the areas where the waves appears to be still, but two waves cause them to clash or interfere. In 1752, despite the danger, Benjamin Franklin demonstrated that lightning is a type of electricity by flying a kite during a thunderstorm. William Gilbert, Lady Elizabeth's first physician, was the first one to characterize the Earth as a massive magnet and to study how electrically charged substances may attract or repel one another. Throughout this much early development, electricity and magnetism are seen as two quite distinct natural phenomena. Michael Faraday, an English physicist and chemist in 1831, succeeded in demonstrating that electricity and magnetism are two aspects of electromagnetism.
Mathematician James Clerk Maxwell, Faraday's pupil, explained Faraday's concept in terms of mathematical equations, distribution of magnetic and electrical charges carried across space. He streamlined his theory in 1864, reducing it to 4 differential equations. Maxwell's work revolutionized the way we think about electricity and magnetism and paved the way for the development of modern physics and technology. Maxwell's equations, along with Faraday's experimental work, and Volta's creation of the first battery in 1792. In 1888, German physicist Heinrich Hertz discovered and produced radio waves that now we use for television, FM, and AM radio. Italian Guglielmo Marconi successfully completed the first wireless telegraphy in the year 1895, and also in 1901 he caught the first transatlantic radio transmission, and the rest go down in history. Now we have Bluetooth, and almost all devices we use are wireless, and that's how the string of violins help create the things you use today.